Good evening, students. Okay, welcome to the homework portal. And today we are working on the first video on the structured questions related to DP2, paper 2 numericals. Okay, so let us start. I think yesterday you had seen the numericals which I had posted and you had also worked out. And today I'm going to look into the solutions for this. Okay. So before attempting these numericals, do not look into the solutions. Seriously. The reason is because, see, these questions are kept in such a way that it kindles your thinking process. As you know, in IB, ATLs are very important. And this really revokes you. It really helps you in understanding a concept. While if you just look at the numericals and its solutions completely, so that thinking process has been lost. So first try it yourselves and then look for the video. And that's the reason why I give you 1 day in advance. Okay. If yesterday I had posted you the questions, today I am posting the answers. Anyway, definitely I will work out the whole solutions, but still I want you guys to work into it and then find out where you have committed a mistake. Okay. Now let us begin without wasting my time or your time. Please share my screen. Right. So this is a STR1 which was being posted yesterday, etc. So the first question reads as such: a company designs a company designs a spring system for loading ice blocks. Okay, you have an ice block, you have a spring here. So you compress it with the help of a motor. And as a result of it, you pull this back and just leave it. And hence, it passes through the ramp and it goes upwards. Okay, that's the question. The block arrives at sea with a speed of 0.9 meter per second. So I will write here as Vc is equal to 0.9 meter per second. And then show that the elastic energy. Now, if this is Vc here, now what could be Vb? That's a question we need to ask. Definitely, it will not be equal to 0.9. The reason is because, see, it will have a larger energy here, and then it has overcome this kinetic energy, sorry, potential energy, and then go over here. So there are two methods. You can either go by a energy method, or you can directly go with the equations of motion. Okay, let me go with the energy method for time being. So, if what is the energy here? Let me assume that this is nothing but your zero potential energy. Now, I'll write half mvb square. This is the energy which is being supplied by the spring, okay, or maybe is the energy which the ice block contains here. This should now be equal to the energy required for the object to climb upwards, which is nothing but your mgh plus the energy at this point, which is half mv square. What did I do? I just applied conservation of energy. Since there is no friction, I can directly apply over here. So this should now be equal to now this m goes away. Now the three sides. So what do I need here? I just need the value of Vb here. So I can now write Vb square is equal to Vc square plus 2gh. The same expression you would have even arrived if you directly used your V square equal to U square plus 2as. Okay. Now let us find out what is this value. What is Vc? 0.9 square. 0.9 square plus 2 into g. Okay, either I can take the value of g as 10 or 9.8. Let me take 9.8 for time being. 9.8 multiplied by h. What is h? 1.2. 1.2. 1.2. So now determine what is this value. So this value could be, where is my calculator? Right. You can also use your calculator and try to get the same answer once again. So 0.9 square, 0.9 square is 0.81. Yeah, it went forward. 0.81 plus 2 into 1.2 into 9.8. Let us do that also. 2 star 1.2 star 9.8. So I get the answer is 23.52. 23.52 together, this comes out to be plus 0.81. It's 24.33. 24.33, and hence your value for Vb is equal to square root of 24.33, which should now be equal to 4.93. 4.93 meters per second. What is this now? The velocity at this point. Now, since it is frictionless, this velocity should also be VA. VA should also be the same, right? So this should also be equal to VA. Now, how did the block get this velocity here? The block got this velocity because of spring here, right? So what does the spring have? Spring gives some energy to it, right? So therefore, the energy given by the spring, which actually should be calculated as half kx square, but this can also be equated to half mva square. Now let us do this. This should be half into 55 kg multiplied by va square. What is va square? I would have just replaced it like this itself. Okay, let me give it to 24.33. 24.33. Now calculate what is this value. 24.33. Oh my god, I squared it across. Okay, no problem, no issues. Now star 55 divided by 2 into 24.33. When I do this, I get the answer as 669.05 joules. Okay, but you see here, this is one significant figure here, and here it is two significant figure here. So here it is 1, 2, 3, 4, 5, which is incorrect, right? So I should write it close to 670 joules. Okay. What has been asked? 670 joules, right? So we have got the correct answer. Now, calculate the speed of block at A. What is the speed of block at A? 4.93. Now, again, what do you need here? You need to keep it only in two significant figures. So, the right answer here should be 4.9 meter per second. Okay. Now, 2 plus 2, 4 marks easily backed off, right? Let us move to the next one. Describe the motion of the block with respect to from A to B with respect to Newton's first law. So how do I describe the motion of this block? Now, in the first case, just a moment. In the first case, now what's happening here? Between A to B, I think my video is blocking the image there. Okay, let me change the image. Let me pull it down so that it becomes clearer for you. Otherwise, you will not be able to understand what I am doing here. I tried to change it there, but unfortunately couldn't. Okay, fine. Yeah, now it's fine. Now this is the first problem. So as a result of it, now you see from A to B with reference to Newton's first law. Now what will happen here? Now there is no friction here. So as a result of it, now I can now write. Now what can I write? I can write here as from A to B, no friction. Hence uniform velocity is observed. Right? That's what you can say. Then from B to C, once again, no friction, but gravity slows down the motion. Slows down the motion as it is climbing uphill. This implies there's a deceleration observed. Okay, so this is for 2 marks. So at least you should write 2 points over here. First one is no friction. The second point is gravity slows down it. Okay, and if you want to add one more, you can say evidence is observed with comparing VC with VB, and VC is less than VB, right? So which means that there's a deceleration being produced. There's no uniform velocity motion, right? So we have very clearly mentioned everything with respect to Newton's second law. Okay, now let us move on to the next one. On the axis, sketch a graph to show how the displacement of the block varies from A to C. From A to B, what did you observe? Uniform velocity motion. So displacement versus time, so slope should be a constant. Displacement versus time, slope should be a constant. And after that, what happens? There's a deceleration, which means now I can just put like this over here. But what you need to do is you need to label it correctly. This is your B. Okay, this is your A to B, and then B to C. And maybe do not curve it inside, keep it like this over here. and this is your C over here. You can either label it here BC, ABC like this over here. Okay, so this is for 2 marks. So you have to exactly put the A, B, and C, the labels appropriately. A to B you will get 1, B to C 1 from 1, right? Okay, so anything else has been asked? Nothing. Okay, then the spring decompression takes 0.42 seconds. So here decompression takes 0.42 seconds. Determine the average force the spring exerts on the block. What is the force it exerts? So towards it, how do I write force? Force is nothing but, how do I write force here? Force is nothing but, let me write here. Force is nothing but M into A, right? Now what is mass here? 55 kg, mass of the ice. Multiplied by what is A? V minus U divided by T here. Now this could be written as 55 into, what is the velocity? Velocity at where? Velocity at this point. Velocity at this point. The moment it leaves it, right? That's where you need to calculate the force. So velocity at this point is nothing but VA. VA. And what was the initial velocity? The ice got compressed completely. Ice compressed the spring completely and then it left. Okay, which means the initial velocity is 0 divided by time taken. What is time taken? 0.42 seconds. Now, do I know the value of VA? I do not know the value of VA. Is it so? Let us check what is VA. You see, this VA and VB are equal. So what was the value of VB we got? Let us check it out. Go back once again. The value of VB we got, oh, we already calculated velocity at the VA is nothing but 4.9. Okay, good. I can see this. Okay, so I can now write this as 54 into 4.9 divided by 4.9 divided by 0.42. So let us calculate what is this value. So this should be, let me take my calculator, 54 star 4.9 divided by 0.42. Here I made a mistake. Just a minute, wait. 54 star 4.9 divided by 0.42 is 641.66. 641.66 Newton. Now, you see this for 2 marks, significant figures, very important. So 0.42 seconds, 2 decimal places over here, and VA is also 4.9, so 2 decimal places definitely. So this should be written as 640 Newton, right? Okay, let us move on to the next one. The electric motor is connected to a source of potential difference 120 volt and 6.8 amperes, two significant figures. Time taken by the motor to compress the spring is 1.5 seconds. Estimate the efficiency. What is efficiency? Efficiency is nothing but output by input. Now, there is something given here, 120 and current. What is that? That is my input parameters. So, input power is equal to 120 multiplied by 6.8. How do I know this? Is nothing but V into I, right? V into I is nothing but power. You already learned in electricity. So, this is power over here, input. Now, what is output power? Output power is nothing but energy divided by time. Which energy is this? This energy is nothing but the energy that the object starts from here, it goes all the way along here. No, nothing is lost in the energy here, but the energy which it climbs over here, or maybe you can find out whatever is the energy here at this point. Okay, what is the energy at point D? So this should be equal to half mVA square divided by 1.5 seconds. 1.5 seconds. Now what we do is we find the efficiency. Eta is equal to P output by P input, which should be equal to half into M, 55 kg, multiplied by VA, 4.9, which we already got it, 4.9 square, divided by time, 1.5, 1.5 divided by P input. What is P input? P input is 120 multiplied by 6.8. Okay, so you should just know which parameters where to multiply. Let us use our calculator, which will be 4.9 star 4.9 star 55 divided by 2 is equal to so much, divided by 1.5 is equal to 440.18. So this one, 440.18 divided by, what is the denominator? 120 star 6.8 is 816. 816. So when I calculate this, how much do I get? Nearly 50% I get. Let us see what is it I got. 440.18 divided by 816 is 0.5394. 0.5394, which is close to 54%. Okay, 54% is the efficiency of the motor is seen to be 54%. Let us move on to the next one. On a particular day, just a minute, the ice blocks experience a frictional force because the section of the ramp from A to B is not cleaned thoroughly. So there is a friction here. The coefficient of dynamic friction between the ice blocks and ramp AB is 0.03. So here mu is equal to 0.030. Okay. The length of AB is 2 meters. 2 meters. We determine whether the ice blocks will be able to reach C or not. You can directly say yes, no, but it's for 2 marks. So you need to justify it. Now, how do we justify it? Now towards it. Now, why should the block go upwards? Because the spring pushed it, right? We instead of saying pushed it, can we say the spring given energy? Yes, you can say it is energy. So the energy given by the spring is equal to, what was the energy given by the spring? We have already done this. Energy given by the spring, it is half into 55 multiplied by 4.9 square. 440 joules energy given by the spring. 440.18 joules is the energy given by the spring. Now this energy, what was happening to this energy? This energy had been taken by this ice and it started moving. Now, as a result of it, it dissipated some amount of energy here, right? What was the energy lost by the object here? The energy lost due to friction is nothing but frictional force multiplied by the displacement, right? So now what is this value? Frictional force. What is frictional force? It should be mu times N into S, which should be mu times mg into S, which should be, what is mu? 0.03 multiplied by 55 multiplied by 10 multiplied by 2. Right? I have taken G equal to 10 over here. Now let us find out what is this value together amounts out to be. Just a minute. It should be 0.03 into 55 into 10 into 2. So how much is it? 33 joules. Okay, so therefore 33 joules was spent in by the friction. Okay, the moment it came here, it did not have 440 joules, but it had 440 minus 33. So what I will do is I'll write this as EB. The energy at this point was seen to be 440 minus 33. ये कितना हुआ? 440 minus 33. 440 minus 33 is 407. 407 joules. Okay. Now what has happened? This 407 joules should be useful in making this object to climb from here until this point, right? Now what is the energy required by the object to start from B and to go to C? The minimum energy required should now be equal to mgh, which should be 55 into 10 multiplied by 1.2, right? So until unless you don't give so much energy, the object will not go there. Forget about what speed it is. You just need to have that much energy. Let us do that value. 55 star 10 star 1.2 will give you 660 joules. Wow. See, you need at least 660 joules to start from here and to go there. I think I'm making some mistake because E spring, what is E spring? E spring is 440.18. Is that right? Half MVA square. That's right. Okay, 660 joules. So as a result of it, now how much energy you have? You have an energy equal to 407 joules only. So there's a deficit of energy. Until unless you do not fulfill this much amount of energy, okay, the object will not move from B to C. Hence the object, the ice block, will not reach C. Right? Okay, let us move on to the next one. Second problem. First problem is done. So how many marks did you back here? 2 plus 2, 4 plus 2, 6 plus 2, 8, 10, 11, 11 plus 2, 13 plus 2, 15. Wow, see, one question, 15 marks you get it. Huh? Right. Now, next one. A tennis ball is hit with a racket from a point 1.5 meters above the floor. It's like this. The ceiling is 8 meters. Okay. He is asking you whether the ball will hit the ceiling or not. 3-mark question. Be careful. Okay. Now, if the ball was hitting the ceiling, It would have gone like this, heated like this, and came down like this, projectile. If it did not hit the ceiling, it would have gone like this, it would have gone like this, and come out here like this. Which means the maximum height it can reach would be the ceiling, right? So we need to just find out what is the maximum height based on these parameters. So the maximum height h is given by uy square divided by 2g, right? What is uy? Uy is nothing but u sine theta. U sine theta divided by 2g. Let us find out what is u. 15 sine 50. Okay, and this is square over here, right? Square over here. 15 sine 50 square divided by 2 into, shall I take 10? Okay, let us take 10 first. 10 itself. And let us find what is the value here. So this should be what is sine 50 value. Let us do that. Sine 50, where is sine 50 here? Go to trigonometry. Sine 50. Sine 50 is 0.766 multiplied by 50 should be equal to, oh my god, I don't know. Wait. Into 15 is equal to 11.49. 15, so wait, let me write it down. 15 sine 50 is 11.49. 11.49 the whole square divided by 2 into 10, which is 20. Okay, let us do this also here. 11.49 the whole square, I didn't do that, square, then divided by 20. I get the answer 6.6 meters. Immediately don't jump to a conclusion that it will not hit. The reason is because what have you found? You have found the maximum height reached by it is seen to be 6.6 meters here. But you see the floor is 1.5 and the total is 8 meters over here. Which means from the floor, the total distance, the height that this racket goes upwards is 6.6 plus 1.5. 6.6 plus 1.5, which is 8.1 meter. But the ceiling is only 8. So definitely the ball will hit the ceiling. So conclusion is ball will hit the ceiling. Then do not write just the answer. You won't get marks if you just write the answer. Okay, this working should be shown. The tennis ball was stationary before being hit. It has a mass of 5.8. Mass is given to you. The mass is given to you and was in contact for time. This much is given. Calculate the mean force. So how do I find mean force, average force, all these things? What you need to do is F is equal to m into V minus U divided by T, right? So what is m? 5.8 into 10 power minus 2 into V. What is V here? V. What is V? V is nothing but this V here. Do not take any component here, okay? It is just this velocity, which is 15. And before it was hit, it was 0. And what time it was in the racket? It was there for 23 milliseconds. 23 into 10 to the power of minus 3. Now let us do what is this value. Use your calculators. Okay. So I have 5.8 star 15 divided by 23. I get the answer 3.78. 3.78 into 10 to the power of, here it is minus 2, it goes upwards, it's 10 power plus 3 into 10, this should be equal to 37.8 newtons. This should be your answer. Okay, next. Explain how Newton's third law applies when the racket hits the tennis ball. Simple. Force of racket on the ball is action. Then what you need to do? Just copy the same thing. Put ball here and racket here. Is reaction. Okay, this is only statement. You can give one more here. You can say action and reaction act on different objects and are equal and opposite. Okay, so this will give you 2 marks definitely. Next, third problem. Curling is a game. Okay, fine. So you have ice, you are just pushing the stone. He's asked you to find out what is the maximum speed V of the stone. Okay. Now you see, if this is V, what is he given here? He has given you the distance. He has given you the total distance is given in 17.5 seconds. This distance is 29.8 meters. Now from a speed time graph, we can find out the distance. How do I find the distance? Area. So the area under the curve is nothing but 29.8, which should now be equal to half into breadth. What is this breadth? Breadth is nothing but B is 17.5 multiplied by height, which is V. Okay. So now let us find the value for V. V should be 2 into 29.8 divided by 17.5. Now let us do this math over here. 2 star 29.8 divided by 17.5 will be 3.4. So the answer is 3.4 meter per second. What about significant figures? So here 3, here 3. Wow. And here it is 2, 3.5 over here. So therefore, let me keep it only in 2 significant figures. Then determine the coefficient of dynamic friction between the stone and the ice during the last 14 seconds. You need to find out the value of mu over here. Now, how do I find the value of mu? Okay. Now, when the why do we get this curve? Because you stopped pushing, and because of friction, the ice started to slow down, right? So therefore, there is a deceleration here. Deceleration. Now, if I consider the free body of diagram of an object, so now if there is no horizontal force acting here, this horizontal force, frictional force, will now try to slow down the object, right? So thus now what we do is we find out that FF is equal to minus mu times mg, which should now be equal to net me, right? So this m and this m goes away. A should be equal to minus mu times g. Now what is A? I can find out from here. We can find out from here. What is the value of A? The value of A here is nothing but slope. Slope. How do I find the slope? Slope is nothing but difference in y-axis by difference in x-axis. What is the difference in y-axis? What was this value? This value was seen to be 3.4, right? So this should be 3.4 divided by, what is the difference here? Difference here should be 14, right? This is what I got the slope. Now what I will do is I will take this value and I want the value of mu, which should be 3.4 divided by 14, and this g I'll push it downwards. So when I do this, I get the answer as 3.4 divided by 140, right? Let us find out what is that value. 3.4 divided by 140 should be 0.024. 0.02. Let me do it once again. Yeah. 3.4 by 14 to g, right? 17.5. Yes, it is 0.024. Yes, 0.024. 0.024. What is being asked? How many significant figures? 2 significant figures. 3 significant figures over here. So this is fine. Okay. So we have kept it here. Then let us go on to the next one. Diagram shows the stone during its motion after release. Find out the free body diagram. So nothing special here. mg acts downwards, normal force acts upwards, and since during its motion after release, right? So there is no horizontal force. Then you see there's a frictional force acts over here, right? So as it passes along, AB over here. So that's it. Okay, so nothing else to be written. Okay, and then you should either include, as you should include the name. You should name this friction, weight, normal. That's it. Okay, you should label it, you should name it. So if you do so much, you'll definitely get full marks over here. Okay, so thus we have come to the end of this issue, the problems. And if you really like this video and you want to comment on it, do comment on it, do share and subscribe this with your friends, subscribe this channel and share it with your friends so that it could also be help them. It could also be more of help to them so that they will be able to do well in their examinations, and see to it that all of you guys do score a minimum of 7. Okay. Fine. Thank you, friends, for watching this video until the end.